Previously I mentioned that it's a good idea to go and look at the existing functionality of one of these operators that you want to overload. That should give you a good idea of what you want to return, so what that function should return, and also more or less the definition, so what you should be doing in the body of that overloaded function. Now of course this really depends. This is just to get started, and maybe if you haven't done operator overloading in a while, instead of going back and looking at your nodes and so on, it's more way of thinking, what does that operator do by default? And if I apply that to my user-defined type, will it be logical? In other words, will it be easy to read? If some other programmer sees it, will they sort of understand what that will do? Or will they have to go and look at the implementation? So it's always a good idea to keep it consistent with existing functionality. But of course that's not always possible. Sometimes you want to do something specific to your implementation, and that's fine. But just to get started again, just to get into operator overloading before you go and do more complicated stuff, that is sort of the approach that I would recommend. Okay, in main I have x and y. X is initialized to 1 and y will be initialized to 5. Now to start off with, what I'll do is I'll print out, so console output, and I'll increment x using the prefix increment operator, and then I'll simply print x out again. Now both of those should print out 2. As you can see, that is what we get. The reason is because if it's a prefix to its operand, then it's going to perform that operation and it's going to return the result. And it's basically going to return the variable itself. So the variable x, for example, is going to increment it. So x is going to be 2, and then it's going to return x back. So that is why we get 2 printed out. And then also in the statement, of course, it'll print out 2. But if we change that to the postfix, and I'll build and run, you should get 1 and then 2. The reason being is it's going to take that variable x, then it's basically going to save the current value of x in a temporary variable, then it's going to perform the increment or decrement, in this case increment again, on x, and then it's going to return the temporary variable back. So it's not going to return this, it's not going to return the variable or the object back, it's actually going to return what it was previously, so that is why we get 1. But here of course x is already incremented and that is why it prints out 2. So one more quick example. I'm going to assign this here to x, so we do the prefix increment operator, okay, and the operand is y. Build and run that. So we get 6 and 6 printed out. And that's because again it's going to increment y and then return that object back again. It's not going to return what it was before it incremented that variable. But if we change it to the postfix, then x here will be 5 and y is going to be 6. So the main thing we are concentrating on here is x, of course. Y is going to print out 6 each time. So it's basically going to return the state of the object, or the variable in this case y, before it does the increment. Actually, just one more example before we move on. In main I have x and y again, and here I'm going to do the prefix increment operator, okay, on x as an operand. And then you can see I can do plus equals and 5, and then I just print x out again. Build and run that and we should get 7, and that's what we get. So x is going to be 1 initially, we increment it, 2 plus 5 is 7. Okay, so we assign 7 to x and then we print it out. So I thought I'd add this extra section because I have talked about the increment and decrement operators in the first module, but I did not show you this, so this here returns an L value. And of course the same is if we do the decrement operator as well. But if you try and do the postfix increment operator, then we'll get an error. Okay, so build around that and you'll see we get an error. Left operand must be an L value. So that will tell you the postfix operator returns a temporary object, whereas the prefix increment and decrement operators are going to return the object itself. Okay, so based on these observations, we can now go and implement the functionality that we want for the overloaded increment and decrement operators, taking both the prefix and postfix versions into consideration. Okay, we'll start with the prefix increment operator. In the first point we have the operator declaration. Okay, that's going to return the user-defined type, but it's going to return a reference. I'll talk more about that shortly. and then we have again the operator keyword, and then plus plus and the parentheses. In the second point, we have the definition syntax. It's going to return a reference to the user-defined type again. So the user-defined type, the scope resolution operator, the symbol, so plus plus again. And notice also here this doesn't have any formal parameters, so it doesn't take in any arguments. That's important because the postfix version does take in an argument. Okay, in the body you're going to increment those members that you want to increment, and then we dereference this. And the reason why we do that, so dereference this and return a reference to that user-defined type, or in other words a reference to the current object, is because this is more efficient firstly, so we are not making any copies, we are not creating any temporary variables, so we are not creating any temporary objects. But that also allows us to immediately operate on the current object. So let's say you have some toString function or some other function that you want to call on the object. As soon as you go and increment that, then you can do that in the same statement. So we've seen this to a certain extent in previous lessons. Okay, next the postfix increment operator. You will see the declaration is similar, but in this case it has a formal parameter, an integer. That changes the signature of the function, okay, so that we can overload it. In other words, we can have both the prefix and postfix increment operators. Then in the definition, we are also going to return the user-defined type. So we do type, the scope resolution operator, the operator keyword, the symbol plus plus, and then also in between parentheses. In the body, we are going to create a temporary object, and we are going to initialize that to this. So we do dereferencing to basically return the calling object. Then we go and dereference this again to again return the calling object, and then we can do the prefix increment operator on that, or you can do implementation specific code, or you'll increment each member individually. That depends on if you already have the prefix increment operator overloaded, and then you are going to return that temporary object. Okay, that's why I cover the prefix and postfix operator on the fundamental types, because from that, if you understand how that operator works on the fundamental types, then you'll understand why this is implemented in this way. Moving on to the prefix decrement operator, this will basically be the same as the prefix increment operator. Again, in the body, we are going to decrement the members that we want to decrement, and then we're going to return a reference to the calling object. And the postfix decrement operator is going to be similar to the postfix increment operator. Okay, again, we're going to store the state of the object in a temporary variable. Then we're going to perform our implementation specific code, so whatever we want to do for that user-defined type, and then we return the temporary object. Okay, for this example, I'll use the entity class again. In the public section, I'll go and declare the operator. I'll demonstrate the increment operator, and I'm going to leave the decrement operator to you as an exercise, because again, these are very similar. Okay, so this is going to be the prefix increment operator. As I mentioned previously, this one is also slightly more performant than the postfix one, because with the postfix one, we have to go and create a temporary variable. For the most part, that won't make a big difference, but if you do something in a loop, again, maybe that can make a difference for you. So the prefix, again, this is going to return a reference to the current object. We have to remember that this is going to operate on the operand or the calling object, and that's going to have its own members. Right, so the operand or the calling object is going to call this function. Then we are going to increment its member. I just have this member here, which is an integer, just for example purposes. So I increment that. That is already overloaded for integers. Okay, so that will work fine. Then once we are done, we are going to dereference this and basically return the calling object again. And we are going to return a reference to that. Now, one thing before we move on is we need to give member here a value. So instead of doing a constructor, I'm just going to give it a value. I'll just give that a value of 1 by default. Okay, so it doesn't give us any errors, but now we have a problem. This member is private, so I'll just go and do a function, or you can remove the private section, but instead I'll just do a quick getter here. Right, just a quick getMember function. You can also do toString, so when you call it, then you don't have to do console output or anything like that. That's also an option. Alright, I'll just leave it like that for now. Okay, so this statement should give us 2 now printed out to the console. Gonna build and run this. And that works fine. Make sure you don't have any warnings or errors. Okay, I'll scroll up to the class definition and I'm going to overload this operator again. Okay, we need to change the signature for the postfix, and so we pass in an integer. If you pass in a different type, we'll actually get an error. I'm just going to remove that reference. We are not going to return a reference. You'll actually get an error if you have a float. You can say extra parameter of postfix operator must be of type int. And I'll make sure to fully qualify that name. Alright, in this statement I'm going to set a temp to the current state of the object. Okay, so it's going to store the current state of the calling object in this temporary variable. Then I go and do the increment on that object. Okay, and this is the referencing, so it's going to return that object. Then it's going to call this overloaded increment operator that we just defined on that object, and we are going to return the temp here. We'll run that and that should work fine. We get 2 printed out. Okay, so I'm gonna make a few changes here just for this example. You can make this a struct if you want, but I'm just gonna remove this here. And then, so the private section, so that that member is now public. Okay, let's say entity1 plus plus. And you can do something like that if you want to. Remember that this postfix is now going to be this one. Okay, so it's going to return temp. Build and run, and we should get 1. But if we do this now, just gonna do entity1.getMember, then that should print out 1 in the first output and then 2 in the second output. Okay, the prefix increment operator is going to print out 2 in both instances. But another thing that we can do is something like this. We can do plus plus entity1. Actually, that is plus equals 5. So we want to add 5 to that result. And that should give us 7. If this is difficult to read, you can enclose that here between parentheses and then do dot member. So it's gonna do the increment on the calling object's members. So in this case, entity1, it's going to increment its members as defined, but then it's going to return a reference back to that calling object. So we don't get a temporary value back, so an R value back. We actually get the object itself back, which is an L value. Whereas if you try this with the postfix, you'll get an error. Left operand must be an L value. Okay, so that's very similar to the observations that we had previously with the increment operator on the fundamental types. Okay, so I hope you found this lesson interesting. I just went about showing you how to think about these things, and maybe in that way overloading will not be that complicated for you. Just one final thing here. You can do something like this, entity1.operator plus plus. Okay, that'll work just fine as well. Prints out 2. Okay, I'll scroll up here to this implementation right here, where we have the argument. Then I'll do the temporary variable and do the assignment, and then following that, we want to check what the value is that gets passed in. For this we need a handle. Okay, so I'll just create a handle here. I prefer to keep these the same, but you don't actually have to. You can leave that one out. I'll just show you this just so you can see. If you don't pass in an argument, then n is going to be 0. But normally, as you've seen so far, we don't really use this parameter. It's only there again to change the signature. But you can use it. So if that is not 0, in other words, we have passed in some value, then we go and increment that so many times. Otherwise, we are just going to increment it once. Okay, so you can do this, or you can do something like that. Just double checking here, this seems to be fine. Okay, I'll just scroll down here. So we're doing entity1.operator plus plus. Build and run, that should give us 2. That works fine. Build and run, and that should give us 56. And that is what we get. Okay, so just another bonus for you. I hope you find this interesting, and I'm gonna see you in the next lecture.